Hi everyone and welcome back to Physics with Mr. Simons, where we make physics simple and we get you exam ready. Right, so now we're looking at Newton's laws, but now this time we're looking at two bodies that's moving up an incline at the angle and they're attached by a string. So there's some tension. Alright, so let's look at the problem. Right, so we have question 2 there, as you can see. We have a 7 kg object attached to a 3 kg object. 3 kg is friction 1, friction 2. They pulled up with applied force of 100 newtons at an angle of 15 degrees. Right, take note, the angle there is 35 and there is 15. Right, so draw a free body diagram showing all forces acting on the 3 kg object and the 7 kg object. Calculate the horizontal and vertical components of that applied force for 4 marks. Calculate the horizontal and vertical component of gravity for both of them, 3 and 7 kgs. Calculate the normal force acting on the 3 and 7 kg objects. Determine force of friction 1 and force of friction 2 if mu k equals 0,31. And then 2.6, determine the acceleration of the blocks and the magnitude of tension in the string. Mu k equals 0,31. And yeah, after doing this problem, I actually had to adjust it to 8 marks. Right, but yeah, now now in English, it's not Englishing, it's failing me. Right, let's look at the first problem. Right, so draw a free body diagram showing all the forces acting on the 3 kg and the 7 kg object. 4 marks for the 3 kg, 5 marks for the 7 kg. Now we won't ask both in exam. You have to do one of the two in exam. But yeah, I'm showing you if you do both of them, you make your exam problem easier. Right, so for the 3 kg, I have tension going up. I have friction going down. I have a normal force. And I have my weight or force of gravity going straight down. So they're going to give you marks for that 4 black lines, right? Now, automatically, I'm bringing in here in red FG parallel, which I'm going to work with later, and FG perpendicular. Right, for the 7 kg, I have my applied force going up, my normal force, I have force of gravity or weight going down, I have friction 2, and I have tension, and you can see that 5 black lines is where I'm going to get my 5 marks. The rest that I've drawn in different colors, they don't want in the drawing, but I'm drawing it because I need it to explain to you how to solve the problem. So there, FA, applied force, has a Y and a X component. Force of gravity has its Y and its X component, or FG perpendicular and FG parallel. Right, so I hope you understand so far. Right, now let's go to the next problems. So first, calculate the horizontal and vertical components of applied force on the 3 and 7, or on the 7 kg object in this case, because that's where the force is applied, not the 3 kg. So X, remember, is normally cos, and Y is always sine. So I can say FAX or FA parallel, right? That equals my applied force times the cos of 15. My applied force given there was 100, so 100 times cos 15 gives me 96,5926 newtons. My force in the y direction, applied force, Fa sine 15, 100 sine 15 degrees gives me 25,8819 newtons. Right? So that's my two components. Now they want me to calculate the horizontal and vertical components of gravity on a 3 kg and 7 kg object for 6 marks. So for the 3 kg, FG perpendicular, which is Y, right, becomes cos. Now remember, for all problems in Newton's laws, Y becomes sine. But for incline, they swap around for gravity. So gravity will always be the opposite of what you do. So the FG Y becomes FG cos 35. And FG X here at the bottom for parallel becomes sine 35, and it's no more cos. Right? Take note there, I use the 15 degrees there on the top, but for gravity, I have to use the 35 degrees given at the bottom. So don't get your angles mixed up. No? Right, so FG parallel equal, then 3 kgs, 3 times 9,8 cos 35, which then gives me 24,0831 newtons. FG parallel, for the 7 kgs, gives me 7 times 9,8 times cos 35, which gives me 56,1938 newtons. Fg parallel, right, for my 3 kg becomes 3 times 9,8 sine 35, which gives me 16,8631 newtons. And this side here, Fg parallel, 7 times 9,8 sine 35, 39,3473 newtons. So I assume it's relatively simple, and you can see where we've allocated marks, right? Given you 2 there, correct substitution in the formula. We're not going to give you there because you technically just changed 3 to 7, so there you only get a mark for an answer. Again, the correct formula, correct answer, 2 marks. But because you're changing 3 to 7, we're not going to give you a mark there, just giving you a mark for the answer. So collectively, 6 marks. All right. So Fg perpendicular, I'm going to need to relate to my normal force so I can get to friction. And then Fg parallel, I'm going to need with my components in the x direction to solve. So I need both of them. I can't solve anything further, no matter what they ask, without finding perpendicular and parallel forces for force of gravity. And if my applied force as well as the x and y component, it's compulsory for me to find it. So we don't necessarily need to ask these questions, but whatever we ask after this, you can't solve without solving this page 2.2 and 2.3. So make sure you know the process. All right, so let's look at 2.4. Calculate the normal force on a 3 kg and a 7 kg object. So for the 3 kg object, normal force simply equals force of gravity perpendicular, 24,083 newtons. But for the 7 kg, because we're pulling the object at the angle of 15 degrees, we still have the force of applied force in the y direction. So normal force equal Fg perpendicular minus Fay. Same as what we did in the previous problems. So that's where we try to catch you out. So that's 56,1938 minus what we found just now in the previous problem, 25,8819, which then gives me 30,3119 newtons, or 30,31 if you want to round off to 2 decimal places. 2.5, determine the force of friction 1 and force of friction 2. Mu k equals 0,31. So 1 was for the 3 kg and 2 was for the 7 kg. So FF1 equal mu k Fn, FF2 equal mu k Fn. Equation is the same. Mu k is 0,31, or the coefficient of kinetic friction, and my normal force is 24,0830. Multiply out, we get friction 1 as 7,4658 newtons. For friction 2, mu k Fn, my normal force, 30,319. But most of the time, if you forget the y component, you're going to put in 56 there and get the wrong value. So from here onwards, positive marking may save you, or you may end up losing all the marks, right? So 0,31 times 30,3119, then gives me 9,3967 newtons, right? 1 mark for each one there. You can see how that 4 marks there was put together. Right, if we go to the last problem. So the key is, all these things we've done is to answer this question. 2.6 says, determine the acceleration of the blocks and the magnitude of the tension in the string if mu k equals 0,31 for 8 marks. Right, so we look at the drawings for the 3 and the 7 kgs. Right. Acceleration, it's accelerating in the horizontal direction, right? So for the 3 kg, tension is pulling it up, while friction and force of gravity parallel is trying to slow it down. On the 7 kg, it's the applied force parallel that's pulling it up, but Fg parallel, tension and friction is trying to slow it down. So we need all of that. So they have got Fg parallel for the 3 kgs. 7 kgs. I have force of friction, 7 kgs, and I have the applied force parallel for the 7 kgs. So for 3 kgs, F net equal to ma, because they said acceleration. 7 kgs, F net equal to ma. My forces there, tension minus Fg parallel minus force of friction must equal my mass times acceleration. Yeah, my applied force parallel minus Fg parallel minus my tension minus my force of friction 2 must equal mass times acceleration. So 1 mark there for getting my net forces correctly. Right, then correct substitution. Fg parallel there was 16,8631 and friction 1 was 7,4658, while the mass is 3 and acceleration simply stays A. On the 7 kg side, Fa parallel was 96,5926 minus my tension minus force of friction, which is 9,3967 minus Fg parallel, which is 39,3473 newtons, equals 7A. Right? So from there, if we simplify, minus 16 minus 7,46 gives me minus 24,3239. There, 96 minus 9 minus 39 gives me 47. If I bring 7A, leave it there, minus T, 7A. Alright? So I'm equating, they have equation 1, equation 2. If I make T the subject of the formula, that becomes 3A plus 24,3289. There, if I take T over and I bring 7 over, that reads 47,8486 minus the 7A must equal positive T. Right, so I can equate the two because the tension is the same. If I take 7A over, 3A plus 7A gives me 10A. 47 minus the 24 gives me 23,5197. If I divide by 10, that becomes 2,35. The 1 doesn't change the 5, so it says 35 meters per second squared up the incline. So 1 mark for F net equal to ma. 2 marks there for correct net forces for the 3 and the 7 kg. Another mark there for substituting properly for both 3 and 7 kgs, and then 1 mark for equating the two equations and 1 mark for acceleration. So that's 1, 2, 3, 4, 5, 6, 7 marks up to there. And then 1 mark for the tension. I take that and I substitute in the place of A. 3 times 2,35 plus 24,329 and gives me 31,38 newtons. Right, so I hope you follow. No, it's a mouthful. It looks like I've done too much, but end of the day, that is the procedures you need to know. Everything I've done previously, the equation wise, we can do straight in here. So we can ask only this question and not ask anything previously. But as you can see, all the items you need to find. This is the procedures you have to get used to solve and answer this question. So I hope you practice it. I hope you master it. Wish you nothing but the best. God bless. Bye.